Hi guys, welcome to my YouTube channel, Techchips. Stay tuned for latest tech updates. Please subscribe and press bell icon to get latest technology news and updates. In this video we are going to talk about machine learning algorithms. So what are machine learning algorithms? Well, machine learning algorithms are those computer programs, or you can call them machine-based programs, which can learn or can get knowledge about the world behaviors from computer data, and they have the capabilities of improving the from experiences. And all that can be achieved without human interaction. Excellent stuff, right? Well, yes, and that where the technology it heading to. Learning tasks could be included learning of the function that maps the input to the output in computer program. I hope you are clear on what are machine learning algorithms. Now let's talk about the types of machine learning algorithms. There are three main types of machine learning algorithms. Number one is supervised learning algorithms. Supervised learning algorithm uses labeled training data to learn the mapping function that turns input variables x into the output variable y. Here is how it can be represented as a functions. Y equals fx. This allows us to accurately generate outputs when given new inputs. Number two is unsupervised learning algorithms. Unsupervised learning models are used when we only have the input variables x and no corresponding output variables. They use unlabeled training data to model the underlying structure of the data. Number three is reinforcement learning. Reinforcement learning is a type of machine learning algorithm that allows an agent to decide the best next action based on its current state by learning behaviors that will maximize a reward. So these were the three main categories of machine learning algorithms. Now let's talk about 5 algorithms in these categories. Number one is linear regression. In linear regression, the relationship between the input variables x and output variable y is expressed as an equation of the form y equals a plus bx. Thus, the goal of linear regression is to find out the values of coefficients a and b. Here, a is the intercept and b is the slope of the line, as shown in the graph. Number two is logistic regression. Linear regression predictions are continuous values, whereas logistic regression predictions are discrete values. Which basically means it work on the situations WGERE results predicted, like a student passed, failed after applying a transformation function. Logistic regression is best suited for binary classification, data sets where y equals 0 or 1, where 1 denotes the default class. Number 3 is CART. Classification and regression trees CART are one implementation of decision trees. The non-terminal nodes of classification and regression trees are the root node and the internal node. The terminal nodes are the leaf nodes. The model is used as follows to make predictions: walk the splits of the tree to arrive at a leaf node and output the value present at the leaf node. Number 4 is naive Bayes. To calculate the probability that an event will occur, given that another event has already occurred, we use Bayes' theorem. To calculate the probability of hypothesis H being true, given our prior knowledge D. Bayes' theorem as follows. PHD equals PD, HPHPD. Number 5 is KNN, which stand for K nearest neighbors. The K nearest neighbors algorithm uses the entire data set as the training set, rather than splitting the data set into a training set and test set. When an outcome is required for a new data instance, the KNN algorithm goes through the entire data set to find the K nearest instances to the new instance, or the K number of instances most similar to the new record, and then outputs the mean of the outcomes for a regression problem, or the mode most frequent class for a classification problem. The value of K is user specified. Number 6 is apriori. The apriori algorithm is used in a transnational database to mine frequent item sets and then generate association rules. It is popularly used in market basket analysis, where one checks for combinations of products that frequently co-occur in the database. Number 7 is kmeans. Kmeans is an iterative algorithm that groups similar data into clusters. It calculates the centroids of K clusters and assigns a data point to that cluster having least distance between its centroid and the data point. Number 8 is PCA. Principal Component Analysis (PCA) is used to make data easy to explore and visualize by reducing the number of variables. This is done by capturing the maximum variance in the data into a new coordinate system with axes called principal components. Number 9 is bagging with random forests. The first step in bagging is to create multiple models with data sets created using the bootstrap sampling method. In bootstrap sampling, each generated training set is composed of random subsamples from the original data set. Each of these training sets is of the same size as the original data set, but some records repeat multiple times and some records do not appear at all. Then, the entire original data set is used as the test set. Number 10. Boosting with ADA boost. ADA boost stands for adaptive boosting. Bagging is a parallel ensemble because each model is built independently. On the other hand, boosting is a sequential ensemble where each model is built based on correcting the misclassifications of the previous model. To summarize, we have covered some of the most important machine learning algorithms for data science in this video. We covered 5 supervised learning techniques, which are linear regression, logistic regression, CART, naive Bayes and KNN. Then we covered 3 unsupervised learning techniques, which are apriori, kmeans and PCA. And also we covered 2 ensembling techniques, which are bagging with random forests, boosting with XGBoost. Thank you for watching this video. I hope you got an idea about machine learning algorithm types. Please subscribe for similar video updates.